I'm in my official capacity, beginning my first stream, and basically it's going to go a lot like this. So, I'm your host for this evening, or this morning, or whenever you actually end up watching this video. My name is Bust a Nut. Don't actually call me that. I don't even know why I have that username. Personally, it's just funny. I don't know what came over to me to make it, but yeah, basically, I'm gonna be making this. I guess I've committed to it now. I guess I got to keep the username. But no, okay. So seriously though, why is this stream labeled the way it is, and why is basically everything sort of titled the way it is and detailed the way it is, or maybe not? So I watch a lot of YouTube videos. A lot of what I consume in my free time doesn't really consist so much of this website alone. I do look at stuff on Odyssey and BitChute and other streaming platforms, especially like Twitch. But I noticed that on YouTube, the reason that I went from watching mostly YouTube videos to basically going from, okay, this is YouTube. This is something that, in one way, shape, or form, is a platform for us to sort of share ideas. So, to sort of succinctly and rationally start from a position, I guess, yeah, this is basically how it is. So, all that was just preamble for the recording. I'm going to actually detail things as I actually see them and as honest as I can, and this is basically the gist. Starting from right now, sip of coffee. No webcam because none of you know me. But here's this deal. So, I watch a large amount of YouTube videos, especially concerning animal life and paleontology, natural history. And one of the things I notice on most of these channels is that people don't really have an objective viewpoint. From the very start, I noticed that, unfortunately, most people in YouTube who make content, and this isn't supposed to be a dig to anyone in particular, but what I've noticed is that they've always parroted the same sort of message. This one of, this is how the Earth was created, this is how the Earth was formed, this is essentially the right answer to what we see going on in our own history based off of what the evidence shows. Now, unfortunately, this is a lie. All of these content creators producing this content and telling you that the origin of life is something that is literally set in stone from the fossil record, and that based on all of this quote-unquote evidence and studies that we have a comprehensive picture of how life was created, how life formed, and how it especially got to where it is today, is something that we well understand. This is a demonstrative falsehood. This is not the case. I know that it sounds weird coming from some Who YouTube channel with a funny username and whatnot, but this is where I'm coming from. I've been studying biology, and now I'm studying zoology as a senior at HSU, for basically my entire adult life. I got into high school at around 15, but I was about 2 months from turning 16. So, because of how my birthday is and everything, I kind of had my first year starting at 19. So it's been about 7 years of study. There was, I guess, a pause there at the beginning of the pandemic. So I guess technically 6. But I've been doing this a long time. I've met a lot of people in academia in my time, in university. I've gone overseas. I've talked to a lot of people. And what I've noticed time and time again is that people seem to have been almost indoctrinated with this message of abiogenesis, of a planet that had been hit by a large planetoid and had coalesced into the planet we see today. Unfortunately, there's almost zero evidence to back any of that up. They talk about evidence, but one of the hallmarks of the Hadean Earth is that most of the crust material produced at that time no longer exists. Tectonic plate activity, which we can observe right now, the plates are moving apart about at the same speed as our fingernails grow, just a couple centimeters per year. And at that rate, we cannot adequately and justifiably say that there's really that much material at all left from those earlier times. There are shields, like there's the large African shield. There's segments and pieces all around the world where there is very ancient rock still from the early formation of the continents. But this period of Earth's history is unknown. This time of the quote-unquote Great Bombardment, where we know that Earth was probably completely molten, that the talk of crust material can't really be discussed. And as such, there is really very little argument to be had for an idea that some large planetoid struck our Earth and created the moon. The reason that we have this theory on the moon is that multiple publications have introduced the very, I guess, accurate assessment that the moon rocks themselves have similar mineral composition to the Earth. Now, we can say, looking at such as Mars material, that we also have very similar elements, maybe in different concentrations. But the issue with this theory is that if everything in this early formation of the Earth, let's say after the sun became an actual planetary body, in the sense that it coalesced and created fusion at its core, that it suddenly created this, large continuous reaction that led to the formation of what we consider now to be our sun. All the planetoids that form out of the dust in that ring, in certain areas, depending on the concentration, would have similar materials, especially if they were in closer proximity to each other. They might have radically different materials. We don't really understand the formation of planets. And this is a big question mark that, unfortunately, has been completely glossed over in our current scientific narrative. There is no real definitive answer onto how planets form. And this goes for all kinds of celestial bodies, which I'll probably get into with another stream/video. But my main takeaway is that we don't understand enough about planetary formation from a strictly scientific, observational, data-based perspective that would allow us to definitively say, this is how planets form. All of these physicists that, and especially these planetary geologists that claim that they have all this, they don't know anything. They have never observed in real time planets forming or coalescing, especially having detailed analysis of minerals and materials and even things like water that may be present in those. We don't know. And scientists who pretend that they know, pretend that they have this brilliant idea of planetary formation and what kind of takes place in the formation of our planets and formation of our celestial bodies, that's all hubris talking. This is raw speculation. They jot down some complex mathematics talking about, okay, well, if we look at the calculus here, look at the rates of change, see how static forces and then gravitational forces will lead to pieces of dust coalescing and then forming into large bodies. Okay, we can see the mechanism for it. We can understand the physics behind a car moving, but you don't know how to build a car just because you know how fast it goes, just because you know the specific heat capacity of the steel pipes or the coolant that's being used in it. You can know all of these facts and still not know how to build a vehicle. And just like this, we don't really know enough about planetary formation to actually and definitively state what is happening when a planet forms. Nor can we say the same of any celestial body. So what we're left with is a big mystery. Because the moon seems to be made out of identical composite mineral materials as the Earth, we have therefore come up with this notion that, maybe the moon came from the Earth, or that the Earth and moon for some reason share this, but where did the moon come from? And there are actually several competing theories with similar weight. One simply postulates that the moon and the Earth formed closely together and that the moon was caught as a satellite by Earth's gravity. That both of these planetoids, basically, sort of coalesced at their own speeds, and that the Earth gained more mass than the moon, despite being in similar proximity, and that they basically were caught by each other's gravity. This is a good explanation for the stable configuration of the moon, as compared to this idea that it came out of the solar system and was caught or something. It just makes more sense. This moon, even though it's slowly moving away from the Earth, seems to be in a rather stable configuration and has been in a stable configuration basically as long as we can possibly remember or calculate. This is an incredibly early event that took place extremely early in Earth's history. So early, in fact, that we have no material evidence that this happened. We don't have a ring around the Earth to demonstrate a massive eruption or a collision between these two bodies. And we sure don't have any evidence from the moon, which, due to a lack of plate tectonics, preserves a lot, but is obfuscated by a large amount of meteors that don't really give us much unbiased, especially, information about the true origins of the moon. There's just really nothing that we can point to that can definitively say, oh yeah, a Mars-sized planetoid crashed into the planet, and by some miracle it didn't completely blow itself apart, but enough material was ejected to where it coalesced in the moon. That's a very cockamamie theory. That is a very fascinating and interesting and creative theory, but it's just as cockamamie as me saying that the moon was created and formed from surrounding gases, that the Earth caught the moon as an early planetoid in our solar system, and they've been rotating around each other ever since. Both theories have equal weight based on the evidence, but only one has been pushed in the scientific literature and scientific narrative. For some reason, I think, it sounds cool. I'm going to be honest, it sounds really interesting. But the issue is that it's not scientific. It's not scientific to try to brush over other opinions, brush over other theories, and especially to try and demonize people who try to present this as being quote-unquote antiquated or outdated in their thinking process. That's bias. That isn't science. That is demonstrative bias against people who have equally valid opinions in scientific literature. But in current academia, it's not about being right or having the truth or having a equally weighted opinion. It's about going with the status quo. And that's unfortunately become the hallmark of science. The replication crisis means that almost 2/3 of studies and papers that you get will have flawed methodology or flawed inferences that end up tainting the data that you get. In science, the goal is not to seek the truth. The goal is basically to get as close to the truth as you can get with the tools that you have. You never prove anything. People just fail to disprove you. So with a replication crisis, what that essentially dictates is that people do not have the resources to vet every single paper, to immediately repeat the experiment, and rigorously go over the methodology. There's no one out there auditing these papers. What they do is they take their methodology, they go out and they have a study, they formulate first, they make observations, as the scientific method should dictate, make their observations, then form a hypothesis, an if-then question, and then they go out and test it. So if I observed that, a lot of these, birds at my feeder seem to be visiting it a lot, I'm wondering if there's actually enough food in the local wilderness that could actually support, life there. So my hypothesis could be, and this is usually where people get mixed up, it isn't just to go out and do a survey or conduct a study or figure something out that way. What you're trying to do is you're trying to ask and answer a question. Not beg the question, mind you. Ask and answer. So I could say, if I stopped providing food at my feeder, then birds will stop coming to my yard. That their impetus to come to my yard is not to feed on the local flora. You're not admiring my daffodils. So the first step I could have is they'll stop visiting my yard if I stop putting out food. Now, what I can then do is put up a camera or record the number of species that go there before and after, and also to have a control. So it could be something as simple as moving the feeder to the other part of my yard and saying, okay, now I'm putting it here. Will the birds go here? Or is there something about that area which keeps them there, especially in terms of, having native plants and everything in the area? Now, conducting the experiment, going through, let's say that, several species have indeed moved locations of the feeder, but my hummingbirds have basically stayed in the same place. I moved their feeder and they will still very gladly go to other parts of my yard, like, say, the bottlebrush. Then you could say definitively at that point, really nothing. Because what you basically proved is that that question you were answering was too broad. That some species did indeed move, other species didn't. And that on a species-to-species basis, it seems like the trend does not render, a definitive answer to this question. But that's still valuable data. You've technically, said, okay, I have disproven myself in several aspects. That is not then the point where you discard your data, throw it away, and never go at it again. You either reformulate her hypothesis and run through, or you submit your data as is, but that's both valuable. Having that record of where you messed up, so let's say, like, okay, well, looks like the hummingbird still likes going to local flowers, whatever, but the feeder thing is a thing, so let's change the feeder location again. If I change it back to the original location, will they go back there? This is how you build upon research. But if the actual methodology from the very beginning is flawed, Like, let's say I was spilling a bunch of seeds as I was moving the feeders from one place to the other. Or I was scaring the birds in some respect. I was wearing bright colors, or I didn't account for certain variables, like where certain insects may be in my yard or something, or where wild fruit may be growing, and maybe I didn't take into account exactly what was. Then all the methodology I'm building off of from that bottom point has that tinge of doubt to it. It has that modicum of disbelief that if somebody repeating the experiment, say in their own yards, which may have more or less native plants, or may not have these very specific factors associated with it, different time of year, all of that, and I fail to record that data, then at that point, they would point out very astutely that my methodology was flawed, that I failed to take into account all of these multiple variables which affected my experimentation. So no matter if I built up that experiment with so many layers you could bury Mount Everest in it, it is still based upon initially a flawed assessment, and from there I have kind of let it snowball out of control. This happens quite frequently in modern science. There are a lot of questions regarding the replication crisis, how well people can astutely and accurately conduct experimentation in the modern day, and also just the general quality of academics. Because it does speak a lot to say, we have the tools, the most advanced tools ever, to conduct very objectively awesome science, and many people are, in many fields. But biology and physics, well, kinda, because physics deals more with mathematics, and the equations are more sound, but I think especially in biology, I can at least speak there. There is a huge amount of misleading and incorrect data out there. There's so much on so many different creatures that either have too small sample sizes, they get p-values rendered that, oh, it looks like there's no significant difference between this and that, or the opposite, they exaggerate it based on either flawed sampling or not understanding exactly the nuances of how to really accurately collect data. And I'm no expert, by the way. I'm just pointing out the obvious, which is when people conduct research that can't be replicated, there's something fundamentally flawed in their methodology. And whatever I can speculate on that is speculation. Unlike many scientists, I can admit when I'm speculating. But basically, the gist of this entire series, which it is going to be a part-by-part series going chronologically through the history of the Earth and sort of just nitpicking the entire time. It's basically a series of nitpicks. I'm not here to give answers. Everybody can come to their own conclusions about what I have to say, but my main goal is to essentially provide you the tools to think critically about what you're hearing from scientists, especially pop scientists, especially these YouTube videos. YouTube is not an end-all be-all source of knowledge. These people may seem incredibly intelligent, but you must realize at the end of the day, they are not correct about what they're saying, especially if it comes from an official narrative that says nobody knows the real answers to anything. I could tell you my take, someone else could retort with theirs. There is no way to make sure that every single take is quote-unquote the truth. Science will always be in search of the truth. One of the great things about science is that it's adaptable to nuances in finding the truth. This entire universe we have is a description of phenomenon and not the noumenon. If you read Immanuel Kant, you'll know what I'm talking about. But Kant basically rolls out the whole mat, telling you that what you see of the truth is just your interpretation. Just like how most things you see, in fact all things you see, are photons bouncing off of objects and hitting your retina and getting interpreted by your brain. All of that is subjective. You are simply seeing the phenomenon associated with an object. If you close your eyes, you no longer are getting that visual data of that phenomenon. You won't be able to tell what color something is, what its size is, what its composition is, if you shut sensory contact with it. You'll have to rely solely on your memory of that object. But if I blindfolded you and asked you which jellyfish are doing which on the screen, you would have no idea, because all you can perceive is the phenomenon, not the noumenon. The noumenon is what the thing is. If a tree falls in the forest, doesn't make a sound, yes, you are simply not there to witness the phenomenon, but the noumenon is consistent. That is the answer to that paradox, by the way. But or at least according to Immanuel Kant. But I subscribe to that because obviously they exist in reality. The reason you're perceiving phenomenon is a result of the noumenon. The fact that there are jellyfish existing mean that I can see and perceive and maybe even hear those jellyfish if I was in the water with them. But you don't have to make too many stretches of logic. You see that, oh, they're jellyfish, they're in water, they have specific colors to them. One interesting thing I've done, and this is partly to avoid, copyright issues or fair use, whatever, because this is fair use, but I've inverted the colors. So the jellyfish are actually orange in this live stream, but they, in this video, are actually flipped in colors. And that was very much intentional, because I wanted to illustrate the fact that this entire time you've gotten used to jellyfish that look a certain way, but in reality, that's not what they really look like. I've deliberately manipulated this footage to make them look a certain way. So, what's this all saying? What's the main takeaway of all of this? What I'm trying to introduce with this beginning of this, series of videos is slowly and meticulously and hopefully entertainingly going through every single aspect that I can think of from beginning to end that is either incredibly wild in terms of its speculation or merely just assuming too much based on the current evidence that we have. People overestimating the completeness of the fossil record to cherry pick what they think is the chronological history of this Earth, to create phylogenetic groups that they then have to, in coming years, completely reformulate. Look at how much of a mess our phylogenetic trees are for dinosaurs, for invertebrates, for literally everything. But looking at all of the new research that's being conducted, people squabbling over how to draw cladograms, purely because it is so unclear about how animals are related to each other, what makes a species, and especially, and what I'm going to be talking about today, how everything in the evolutionist narrative started. So I've talked about formation of the Earth, how there's two competing theories, I guess, at least that I know of. There's probably many more interpretations of how the moon came about, how the Earth formed, but mostly what I want to discuss, and this is relevant to the thumbnail that I selected, is Hadean Earth. Basically, after the Earth cools, just 400 million years, based on fossil evidence that we have in Canada, we see the first prokaryotic organisms appear on the Earth's surface about 400 million years after the Earth cooled. This means that at around 3.9 to 3.8 billion years ago, we saw the first life, despite Earth only really cooling down starting at about 4.2 to 4.1 billion years ago. So this is a very, 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 almost unimaginably long time ago, ladies and gentlemen. This is not some... This is almost an unfathomable length of time. Keep in mind that these same scientists who can't predict the weather 2 weeks in advance are telling us that in a billion years, just a billion, that the sun will begin to become a red giant. This happened, no cap, as the kids say these days, 4.1 billion years ago. So not only just 1 billion years in the future to our sun supposedly starting to die, but four times that. That's an incredible length of time ago, especially to make any broad statements. But this is what we see based on what the geologic record. So we can see from the oldest crust material, it goes about that far back. Because guess what? Most of the Earth, by that time, was only just consolidating. Tectonic activity was still going even from that early time period, just because of how the Earth's mantle and how its core all interact in a giant convection system that has pushed these plates apart from the very start of the Earth's history, and very little of that crust material remains as a result. It's almost assuredly been subducted, melted, and reformed into crust somewhere else on the planet, and therefore we can't gather any really meaningful data. We have to look at these old shields and the oldest rocks that we can find on the continents to formulate a minor snapshot of what was happening in just one segment of the Earth's crust at this time. But what we do see, even with the earliest evidence, is that life was on this planet almost from the very beginning. The statistical probability of life forming just 400 million years after the Earth cooled is astronomical, because abiogenesis, this entire theory of abiogenesis, assumes that life could come from nothing. And Louis Pasteur already proved that wrong way back when he did his first experiments boiling flasks and seeing if life will just spontaneously emerge in chicken soup. He provided the perfect environment for bacteria and other microbes to grow, but he noticed that if you boiled the flask and sealed it off, that no life would grow in there. And guess what? To this very day, there is no microbes growing in Louis Pasteur's boiled and sealed flasks. There is no life, cannot come from nothing. Life does not spontaneously emerge. This idea that maggots spontaneously grew in meat, that life and microbes would spontaneously emerge, comes from an era where people were actually ignorant about how life worked. And yet we sit here in the modern day and we talk about how life came from nothing around volcanic vents and tide pools. It's a step backwards, not a step forwards, to claim that life, oh hello jellyfish, to claim that life came from nothing. These people genuinely want you to believe that life came from nothing. They, in their own experimentation for decades and decades, these are experiments stretching all the way back from before World War II to try to create life artificially. And even with the most modern advances in science, the only way, what's slowly becoming apparent, no matter how many times you create the perfect soup of, everything from amino acids and phospholipids and, everything you need for life to persist, we don't see life randomly come up. No matter how many times you shock it with electricity or expose it to UV radiation, even the most basic self-replicating RNA chains, let's forget how volatile they are. Even the most basic self-replicating RNA chain is something that is so statistically unlikely to form that, honestly, I'm surprised they even have the nerve to say it, because the issue with RNA is that it's volatile. This is why so many cellular processes have to be protected by an isotonic solution wrapped up by a phospholipid bilayer with some ability to keep everything consolidated, because the things that require the most protection are oftentimes the most complex systems. Something as complex of a molecule as RNA needs a stable and safe environment to form. You do not get that in a tide pool getting blasted with UV radiation because the ozone layer hadn't formed yet. So there's no way it formed in a tide pool, first and foremost. It was getting blasted by UV. And even if ozone formed, it's still, free-floating RNA does not assemble itself into self-replicating chains in an environment that hostile. Around a volcanic vent, absolutely too. Because it's not just, oh, it's getting hot, it's getting cold. It's reacting to things in the environment. If you have an environment that scientists are saying is highly reactive, that, oh yeah, it's such a chemically active bed, then something like free-floating RNA is going to just be absolutely massacred by that. So what we're seeing here is not some, magical moment of science where everything just comes together and works out. It's instead something so astronomically improbable that it would take billions of years to happen on its own agencies. Even the most conservative of predictions, or even rather the most liberal of predictions, they completely and obviously point out the fact that a 400 million year time span, and this is just what we have fossil evidence of, again, pointing to how sparse the fossil record is, life could have appeared right as soon as the oceans. We have no clue. This is just the earliest data that we have found. But this time span is so small. It's such a short window for what we've predicted is possible under a random assemblage of life that there's really no way that this theory holds water. How can life randomly come about, even from the perfect material soup, without some sort of kick in the right direction? This is partially, I guess, in a weird way, if it ever happens, a really convincing argument for intelligent design. Because if you have people making life in a lab synthetically, and it works, that does not disprove I don't know what they're trying to get at. It's like, are you trying to improve intelligent design by disproving? It's funny because science will always sort of point you in the right directions when it comes to things like this. So, I mean, some people believe in panspermia. People believe that, maybe life came here. But that doesn't really answer that question. But at the end of the day, you're kind of confronted with multiple different theories that, maybe, oh, what if life formed before that? Maybe life formed where everything was all magma, but then it doesn't make sense that they're organic, that it's organic life. So whichever way you slice it, the very origins of our I guess, according to evolutionists' earliest ancestors, other people, just the first life, this could be honestly the biggest mystery in all of science. Even more so than the Big Bang. Because, I mean, who cares what happened billions and billions and billions of years before life? This is where it starts. Earth. Here. This rock, this planet, this solar system. This is where it started. We're asking these questions in the first place because of life. Life begets life. This is what we know. Life comes from life. Life never just comes from nowhere. So, I see, honestly, where evolution has come from. When it comes to this idea that, okay, we know that life comes from life, so obviously life must evolve from earlier life forms, and these species must radiate out. But what's so fascinating about that, and all the inconsistencies that I'll go over in later videos, is that this beautiful, neat idea that the evolutionist puts out is not reflective of reality. Because there's multiple obstacles and holes that disprove many aspects of current macroevolutionary theory. And simply saying that it's scaled up microevolution is not sufficient, because it also ignores the basic principles of microevolution that are infraspecies specific, which means that they happen solely within what we define as species, because the term species is not an objective term, it's very much subjective. Just ask any scientist to define a species and you'll find multiple examples where that is contradicted or refuted outright in the literature, or with current examples of species that just don't fit that definition. So we'll skip that for a later video, which I want to include anyway, but focus solely on the earliest prokaryotes. These life forms that somehow formed at the earliest stage of Earth's history and were the ancestors of all life. See, there's two fundamental issues that we run into when it comes to talking about the earliest life. One of them is the sensitivity of the earliest microbes to the environment that they find themselves in, and the other is merely the types of organisms that ended up emerging. So, what we see in science is a concept called irreductible complexity. These are structures within cells and within organisms that cannot be reduced to simpler parts without them no longer functioning. And this is something that is commonly brought up with people who critique these early times in Earth's history where scientists assume that things can, start from a super early point like a self-replicating RNA and work up, but the actual structures that have to be encoded by that RNA have to appear as a single gene. Otherwise, they're only partially formed, and that is what we call in science a pseudogene. A pseudogene, we have multiple pseudogenes in our genome, but these are genes that are no longer functional because parts of them are either missing or just other genes are regulating them to the point where they don't activate. But what we see in our DNA, and even just looking objectively at our DNA, you can't just get 90% there with the gene. Even a 1%, even a single allele being stripped of this, it can mess up everything. Your DNA requires sets of 3 amino acids, at least on the part being transcribed, 3 different nucleotide bases contributing to the formation of each chain of that protein. Amino acids form long complex bridges in your ribosomes that essentially become that segment of DNA, and then, or at least one side of the helix. And then we can go on from there, and it's, I'm not trying to have a giant lecture in cell bio for y'all. I'm just trying to point out the simple fact that you can't get almost there with a gene. If you're missing even one amino acid in the chain, if you're missing even one nucleotide sequence in that chain, an A where a G should be, a G where an A should be, that's mutation. But that's not the point. The point is that if there's nothing there, if you only have 90% of a gene, and that 10% is missing at any point, you will no longer have a functioning gene or a gene that performs that specific function. And that makes it very difficult to make this argument that self-replicating RNA getting somehow encapsulated by a phospholipid bilayer is the origin of all life. Because even within those prokaryotes, there are a multitude of enzymes, a multitude of cellular structures that have to be formed in order for life to be viable. Because it's not just life having to form, it's also life having to be viable in the environment it finds itself in. How is that cell acquiring new material? How is that cell moving between areas where nutrients may be more or less present? That is essential for all living organisms. If you spawn next to a volcanic vent, you need to be in some ways a thermophile, or in many ways, able to metabolize chemicals, because you're so deep in the ocean that you can't photosynthesize. And even to photosynthesize, how are you doing that? What is your system of respiration? How are you acquiring the energy to do stuff? Not just the minerals and materials to build your own body, but how are you actually fueling your existence? This is a very big question, because there is an irreductible complexity when it comes to all these systems. You have to have a fully working respiratory system, and not just like in a human sense, but you need to be able to metabolize effectively anything that comes into your body. You need to be able to turn hydrogen sulfide into formaldehyde, and then break that down and have all these ATP processes going on in your body. And you need to be able to push waste out and bring new material in. This is an incredibly complex system. Rome is not built in a day. And I don't believe the extremely complex machinery within a cell can be almost immediately generated from thin air or thin water or whatever medium you want to talk about. It isn't merely enough to have the materials to build life. You also need to have all of these complex systems emerge at the exact same time and in the exact same sequence to facilitate life. Because the second part of the equation is just as complex as the first, and that's reproduction. It isn't merely enough to have a life form emerge and have all the systems necessary for respiration. You also need to have all of the machinery in place to perform cell division. Cell division is possibly one of the most complex phenomena that we see within cellular life. There is almost nothing more intricate and dynamic than one cell becoming two cells becoming four cells. It is the origin of all humanity. From the time we are nothing more than a fertilized zygote to the day we are born, we are continuously starting and dividing and starting and dividing time and time again. Cells going through a complex dance of respiring, living their lives, dividing, dividing, dividing. And as cells die or reach the end of their rope, having divided countless times before, they senesce, and then they die, and then they are excreted and shed, and soon a single cell becomes a multicellular organism, becomes what we see to be a cute little baby, and that eventually goes on to be an adult that makes its own babies. That is the circle of life. Cells becoming mini cells, using cells to make more cells. Life begetting life. So this is how life works in a nutshell. Life respires, it goes about its business, takes in nutrients, expels waste, and reproduces, keeps doing that, cycle over cycle over cycle until it dies. The most basic prokaryote follows this mechanism because it's a fundamental aspect, and simplesiomorphy to all life. The most basic simplesiomorphies of life include these processes. And trying to convince me or anyone else that these are random processes that came from nothing is possibly the most ridiculous thing I've ever heard in my life. Now, there is a fundamental difference between saying these things, pointing out critiques, and then not offering really much in terms of answers in return. And all I want to do is point out that, well, you can think that not having an answer is a bad thing. Or you could think that, oh, well, this just proves that scientists have nothing good to say or whatever. You're trying to be anti-science or against academia or something. And all I want to say to that is basically, if you're so afraid of hearing an opposing opinion that you want to censor it or discredit it or knee-jerk say that it's wrong, or that I am not trying to create a straw man for you to attack or abuse. I'm not trying to promote my theory of what happened, because guess what? That isn't the point of this series. A critique is not required to have this magical rainbow response. You know, like, I'm not here to preach to you about what I believe. I'm simply trying to point out what's wrong with pop science and mainstream academic thought, because it prevents people from seeing others with legitimate opinions and equally valuable research as legitimate scientists and people who actually have the best interests of the public at heart. People have been lied to for a very long time about what is right and what is wrong, because they're presented in school this idea that what these scientists have to say is the truth, that their ethos is a sufficient replacement for logos. And today, I just wanted to give a sort of short and rather succinct introduction to what I believe is to be a giant fraud being committed on the hand of many academics and many people in academia whose only goal is to either better their reputations or to simply silence or discredit other opinions. Having letters after your name does not make you right. It does not make you the Nostradamus or a religious figure. It is simply something that denotes that you have gone through the rigors and the proper channels to become sort of seen as a scientist. The first scientists like Antoine Lavoisier, like Galileo and Erasmus, these guys were not considered PhDs. You know, some of the most fundamental scientists in history did not have any letters after the name. They were persecuted. They were hated. They were reviled. They were seen with mistrust. Galileo was imprisoned. Antoine Lavoisier was beheaded. You know, everybody that talks about, oh, I'm a science this, and, you know, I'm going to go and post this on, you know, /sci or on Reddit, or I'm going to tweet this or that, and, oh man, we're sciencing now. I hope people understand that every time they get caught up in these narratives, that it's just one side or one view take or one opinion that they're hearing from these people. So that's about part one of this series. An introduction, a formal nod to sort of the modern scientific conjecture. And I'm not, again, trying to cast shade on anybody who is posting content on any platform on the internet. This isn't directed to anyone specifically, but rather pointing out something that I have found to be an institutional issue, something that they're pushing down people's throats in universities, something that they're widely promoting in the media, something that many people are advocating as the absolute end-all be-all to these questions. That if anybody else has a contrary opinion, that they're being unscientific, or that they are lacking expertise, or that even outwardly wrong. So you can critique my critique. You can think that I have made an incorrect assessment, but you still have to address the issues that I have brought up, and you still have to do so with a serious, like, reasonable doubt attached to it, which is your right. I'm not correct on everything I say, but I'm willing to defend my talking points. I'm willing to sit here and let you know that what you're hearing from these people has to be critiqued. If you're willing to critique me, if you're willing to question what I have to say, you should be equally questioning of everything else you hear on this platform. Because even though I love the content posted here, many of the creators and artists and just simply voice actors, whatever, are amazing. I have to put my foot down and throw my hat in the ring and let people know that this is what's going on, that this is what's facing modern science, and that they should keep an open mind. So, as I'm wrapping up this stream/video, I just want everybody to know that I hope that they have a good day, that everything goes well for them in life, and that, and that I'll see you in the next parts. So, with that said, I bid you a wonderful